So our topic for class today is polynomials. So we're going to say p of x is any polynomial function, and it can be written in this form. And here's the important notation to notice. If the first exponent is n, each exponent decreases by 1 in order, down to when you have 1 and then no variable. This a sub n just means it's the first. This is the leading coefficient. This is the next coefficient, all the way down to the constant. N being the highest exponent is the degree of a polynomial. The nth degree polynomial makes n minus 1 terms. So let's look at some examples. Quadratic is x squared, cubic x cubed, quartic is x to the fourth, and this is x to the fifth. So by n minus 1 turns, you can see that a quadratic has 1 curve to it. But a cubic would have 3 minus 1, which is 2. 1, 2. Quartic has 3. 1, 2, 3. And then the quintic, which is to the fifth, would have 4. So make a rough sketch of these types of graphs, of these top polynomials. So now for number 1, A, B, and C, we're going to follow these 3 steps every time. Please write these 3 steps down. You're expected to know them and know what they are and how to do them for your test next week. Okay, so to start for A, what are the x-intercepts? That's here at -2 and +2. So we're going to write our polynomial as y equals, A is going to be the leading coefficient, and then I'm going to write my zeros, or the x-intercepts, in factored form. So that's going to be x minus -2 and x minus 2. It's always x minus. You can then simplify this to x plus 2. So we would have y equals A times x plus 2, x minus 2. But now we need a value for A. So to get the leading coefficient and this value for A, we can plug in this really nice point here at the y-intercept, which is 0, 4. 0 is the x, 4 is the y. I'm going to plug those values in and simplify for A. So -1 equals A. But our final answer is going to be the A substituted into the equation. So the polynomial equation for the first problem is y equals -1, x plus 2, x minus 2. Okay, let's repeat that again for B. We have this x-intercept at -3, at 1, and at 2. So to hold our coefficient, I'm going to have 3 factors, because those are the zeros. That's x minus -3, x minus 1, and x minus 2. It doesn't matter if you started with x minus 2 and then did x minus 1 and then x plus 3. The order of your factors does not matter for solving your problem. I'm going to change this to plus 3. And now to solve for A, we're going to use our y-intercept, which is down here at 0, -12. When you plug 0 in for each x, it's 0 plus 3, so we get 3, 0 minus 1, 0 minus 2. 3 times +2 is 6, so when we divide by 6, we get -2 is A. So your final answer, replace that A with a -2. Okay, and then lastly for C, I needed more room. I'm going to do that on this page. I'm going to follow the same steps. But there's something special here about this 0. I'm going to go back 1 second so we can compare. See how for in B and A, the graph goes through. It's a positive y value, then a negative y value, a negative y value, then a positive, positive, then negative. It crosses the x-axis. Well, here in C, it just touches the x-axis at 2. It's a positive y value and a positive y value. So this is something special. It's called a repeated zero. And we're going to have to repeat it in our factors when we solve. So I really have 3 zeros. I'm going to have x minus negative 3, and then x minus 2, and x minus 2. For the x minus 2's, you could write that as x minus 2 squared. It's the same factor times itself for squared. Now to solve for A, this one's impossible. I cannot see the exact point and know that exact value. So because I don't know that exact value, I can't solve for A. This is going to be our final answer. Okay, so here we go, another polynomial problem, but now a word problem. A company is producing CD players, and they determine the profit, so that's the money they earn after their cost. Remember, profit is revenue minus cost, is given by pi, stands for profit, of the price is negative p squared plus 170p minus 125. Now you could graph this in your calculator. I know it's a quadratic, so it's a parabola. I know it's going to open down because of this negative. So it's a down opening parabola. Use the graph to determine the price to maximize the profits. So because it's a parabola, this is the vertex. The vertex is what I'm going to look for. If you want to use your calculator, you may. You can plug this into y1 and graph it and change the window, but there's a much, much faster, simpler way. To find the vertex, the x-coordinate is negative b over 2a, and then the y-coordinate is the x-coordinate plugged in. So f of negative b over 2a. So in this case, your coefficients are a, b, and c, just like when you use quadratic formula. So the x value of the vertex is negative b divided by 2 times negative 1. Well, negative divided by negative will be positive, and then we're going to do 170 divided by 2. So when you divide 170 by 2, we get 85. So if I'm going to make a rough sketch, 85 is the x value of the vertex of this parabola. So now to find the y value, whatever the maximum y value is here, we're going to take 85 and plug it back into the function. So we're going to do the profit of 85. Notice where I put the parentheses when I'm plugging in the 85 to the p squared. And that's going to equal 7,100. So the maximum profit is at the price of $85, and the profit will be 7,100. And because it's an upside down parabola, I'm just going to sketch the quadratic. Okay, so for number 3, the company has found that the average number of passengers per night is 75 if the price is $50 per person. At a price of $35 per person, the average number of passengers is 120. If we assume that the demand is linear, we can either use slope-intercept, or maybe we'll use point slope. Y as a function of x. So when I go to write my coordinates, price is in the x spot and Q, or the demand, is in the y. You would always read this sentence as y as a function of x. So, getting our 2 points so that we can calculate our slope. The price is $50 if there's 75 people, or the price is $35 and 120 people. Now we need our slope, and I'm definitely going to use this for my final answer because I have 2 points. So the slope is 120 minus 75 over 35 minus 50. And so when we calculate slope, we get 45 over negative 15, which equals negative 3. Now you can pick either the first point or the second point. I'll pick the second one. So we have, and I'm going to use the letters of the problem. So this is Q and X is P. So my answer is going to be Q minus 120 equals negative 3 P minus 35. And now if I wanted to simplify that, we can distribute the negative 3 and add the 120 over. But let's see what part B is asking. Oh, write the revenue. Okay, so I am going to need to isolate Q so that I can multiply it by P. So, take a second to do that. We're going to distribute the negative 3. And we're going to add the 120. Plus 120 is 225. So now here's our quantity, or our demand, isolated. So for revenue, it's going to be P, the price, times, oops, this should be a plus, I'm sorry. So we'll do one more step. Let's distribute the P. That's negative 3P squared plus 225P. So the revenue function is quadratic. So now that we have the revenue function, we're going to decide what price should be charged to get the greatest, vertex again, revenue. So you can graph negative 3P squared. I'm going to rewrite my formula here. R of P, negative 3P squared plus 225P. You can graph it, change your window. I'm going to do my negative B over 2A. This is A, this is B. So calculating this x coordinate, we get negative 6. Is positive 37.5. So if I have a general sketch of my upside down parabola, the vertex, or the maximum here, the x value is 37.5, and that is price. So then if I find the revenue, the y value, I'm going to take the 37.5 and plug it in for P. It's going to be very helpful if you have your calculator. And when we calculate it, we get the revenue of $4,218.75. And the question specifically says, what price should be charged? So actually, I could have stopped at the $37.50. Okay, so you try number 4. So hits the ground is an x-intercept, and the highest point is going to be the vertex. So again, you can plug this in y1 and look at it. For hits the ground, I'm going to find when y is 0. So we're going to factor. I can factor out a 16t here. Oh, wait a minute. I forgot my negative. I can set each factor equal to 0. And then you get time is 0 and time is 3. So 0 is an x-intercept and 3 is an x-intercept. That's a general shape. It's an upside down negative parabola again. So for the vertex, negative b over 2a, negative 48 over 2 times negative 16. That is 1.5. And then the maximum value, we have to take 1.5 and substitute it back in. So when we do negative 16 times 1.5 squared plus 48 times 1.5, we get 108. This is time. This is position. Remember, we're going to be precise. Label as much as we can. Okay, so the following page in your packet is homework. Looks like this. You're going to do the odds and skip 17.